properties. Let's use, okay, so now my mic is on. Okay, we're getting somewhere. So let's see, we're going to, I'm gonna introduce you to C#. So the first thing that I'm gonna have you do is just Google how to install Visual Studio, click go to download, and download the free community download. It's really easy. It's got installation instructions and all this kind of stuff. I obviously already have it installed because I use this quite frequently, so I'm not going to be installing it, but it's a very easy thing to get set up. And you know, this is not an introduction to this is not an introduction to Visual Studio. This is an introduction to C#. So when we're going to go ahead and hit create new project on whatever platform you're using, and I'm just going to create a console.net, a console app, just really quickly here, and sure, we'll call it console app 1. And I just want to show you what we're going to be making. So it's a very simple time logger. So I launch it here, it opens and immediately closes, and it drops a file on my desktop here. This file then shows me the time that I launched the program. And I can use this as many times as I like, and each log is logged separately, and it indents the line so that it is ready for the next time that a log happens. So this is not too complicated, but it can be complicated for somebody who does not understand code yet. So we're just going to go ahead and delete this file, and we'll open up the code on the other side here. Let's see, where's, boop, there we go. You know what? Let's do this the fun way. We'll have it set up like that over there. So that's I've got a vertical monitor to show off the code. Let's see if I can get my camera to work. Properties, deactivate, activate, configure, defaults. Okay, no. Okay, yes, there we are. Okay, so as you can see over there, over there, in that direction, I have code open. I'll just pop this guy up there, and I'll zoom in here. So I'm going to start by deleting everything. Oops. Hit the run button. Okay, so I'm going to start by deleting everything. So this is an introduction, so I need to bring you up to speed on how it all works. So as you can see, there's a number up there at the top left, right here. The way that computers work is a computer program, or a computer reads from top left down to bottom right. So each of these lines is the order in which the program is going to be executed. So that's you know, the basics of programming right there. But with C#, it's kind of, with many programs, you want to start with something that's just as simple as hello world. This is a very basic thing that every programmer knows about, and you just say hello world and print it to the console. However, if I run this, it says there are errors and it doesn't know what to do. So in C# you can't just write hello world, and no program actually you just write hello world. You actually have to program in the knowledge. You have to tell the computer how to say hello world. So in C# you need to be referencing libraries very similar to C++, but we'll get into that another day. What we're going to be referencing to start off with is system. And to do that, we just write in using, so we're telling the computer that we're using the computer's system. Very simple. And then I added this little semicolon here, and that's kind of like a period in just English grammar. You know, you end a sentence with a period. If I didn't do that, then it would be, you see it throws an error down here, CS1002 semicolon expected. It requires proper grammar. So we can save that, we can run it, and we'll see that nothing happens because still we have no main entry point. So we'll implement one. To do that, C# uses classes. So we'll have a public class, and public meaning that anybody can read this, anybody can access this at any time without anybody's prior knowledge, which is kind of awesome. So we're just going to say a public class, and we'll call this text or time printer. We'll call it that, sure. Time printer. Okay, and now we need to define what's within this class. To do that, you can just go ahead and start typing in right here, void, blah, 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 have a whole bunch of stuff in there. But it's a lot more clear and concise if you just add a bit of curly brackets. So curly brackets in C# are used to define, let me just make this a bit bigger, are used to define the contents of a program. So in this case, the contents of time printer, this class here, is nothing. There's just nothing here. But this won't throw an error because, well, there's a class. But it will still throw this error, wherein it says program does not contain a static method main. So that is where computers, most computer programs or programming languages require you to have a point that says main, and at that point it will start running your program. It's kind of, it's not a say all and end all. You know, not every program requires it, but, or not every language requires it. Like if you were speaking batch, for example, you don't need main. It's just going to start reading from 1 all the way down. At any rate, let's go ahead and implement this method called main. So what is a method? A method is anything that ends in this. And that is a bit complicated, but we'll get into it another time. For now, let's just go ahead and implement it. We need a public void, so we're not going to be returning anything. This isn't a class or anything like that. This is just a hole for the computer to read and then leave. Okay, so it's a public void, and we're going to call it main, and we're just going to open and close it, just like that. So like I said, a function or a method starts and ends with these brackets here, and then to explain what the content is, we need these curly brackets. So let's save this project here, hit F5, and we still have some errors. So we actually need the uppercase of main here. No, we don't want to run the last successful build. And then I believe actually we need to be accepting some variables. So args, let's see, string array args. I think after I've implemented that, well, it still says it's got no entry point. Let's see here. Just a second, live programming. That's just the way it works. Okay, yeah, I'm doing it right. We're not going to go into things like that. Oh, it wasn't static. That was the issue. So static means that anybody can access it from anywhere. It's a yeah. So spoiler alert. To access the hello world command, or to print hello world to the console, you write console dot write line, open and close some brackets, because this is a method that we're calling, and you can just write in here in quotes hello world, and the quotes just means that you're feeding in a string, so a word of any kind, you want to surround it in quotes, and then that's what this string box brackets args is just a word. So we can now hit F5, and this program will run on Visual Studio at least, except you might have noticed it just immediately disappeared. So let's, oh geez, what have I done? Lower this a bit, hit F5 again, see it pops up, goes away. So what's going on here? Well, we're reading from top to bottom, right? So we go 1, we're using system. 2, nothing. 3, we're defining a class. 4, we're defining an area. 5, we're defining the entry point for the program. 6, a secondary area. 7, where did I get 3 from? At 7, we are writing the line to the console. And then after we've wrote that line, we're going to 8, we're ending that area, and we're ending the next area. So we're never actually stopping to say, hey, we need to do more with the program. We're just printing to the console. So if we never actually stop the program, we never get to see that it said hello world. So let me raise this up a bit for you again. So we need to add a stopping point. So my favorite way to do this is just by adding a while loop that says true and open and close some brackets to show that something is happening here. So what a while loop does is it iterates through something until a specific parameter no longer equals true. So when I say while true, I mean never leave this loop, ever. This is an eternal loop. You will be born into this loop, you will die in this loop. So this will essentially stop our program. So let's hit F5, and we can see our program now says, hello world. Awesome. So we can close out of that, make something a little bit more fancy. I can take this hello world and put it inside of my while true loop, hit F5 now, and we see the program is writing hello world a million, zillion, trillion times. So make it a little bit more fun, I can add a number to it. So let's say long, because this number is probably going to get pretty big, so it's going to be a long number. Let's say number, and let's just start that out at 0, so equals 0, and then we need to end our sentence, so a semicolon. So we're telling the computer we're going to need a number that starts at 0. Okay? Now how do we see this number? Well, we'll put it here. But first we need to actually, you see, you can't just add number here, because you see I've got a little red line here and it's got red underlines like in Microsoft Word, you know, like you've done a typo. It just doesn't expect a number here. So what you do instead is you can convert this into rich text by adding a money sign here, and then adding some more brackets here. Then within these brackets you can add your number. And that is what rich text does. You see, if I took this away, it turns orange or brown. What, I don't know what color this would be. It's like a reddish brownish color. It's a color different from white. So I'm gonna hit Control Z and add that money side back in. It turns white. That's how you know that it's rich text. So if I ran this though, the number would never increase, and that would be quite boring, so there's really no point in doing that. So I'm just going to right below this, write in number, plus plus. So increase this number by 1 point each time we run this loop. So you can see this number is getting quite big. Really, really quite big. And eventually, it's actually going to reach its cap, and it's not going to be able to get bigger anymore. And we've used a rather large value here, so it's not going to reach it in our lifetime, but, well, the lifetime of this video at least. But it will eventually reach this number here. See, I just clicked on the number and hit F12, and that brought me to this value, which if I zoom in here, you can see the maximum value for this is, I'm not even going to try to say this, but it's this number here. So it's so phenomenally large that you will never, ever, ever run out of space in the course of this program. In the case that you do, you can easily just restart the number. So why would I never ever need a number this big then? That doesn't really make any sense. Numbers don't need to be that huge, Forrest, you might be saying. You're right. So instead, let's use a short. Let's use a short number. Hit F12. You see the maximum value for this is significantly smaller. It's only 32,767. And you might actually notice something immediately here, is that the minimum value is actually one digit technically higher, so it's negative 32,768. So why is that? Well, that's because 0 actually counts as an index. So if 0 wasn't an index and numbers started at 1 instead of 0, then this would also be an 8 here. At any rate, so now if I were to hit play on this and let this play out, we will see that it actually goes in circles. It eventually has to restart back at the minimum value. That's not what we want, though. We want this number to go all the way up and then go hit 0 and then go all the way back up again. So to do that, we can use an if statement. So if, and let's open up some brackets because this is technically a method, number is greater than or equal to short dot max value, then let's open this up, number equals 0. Okay, now let's hit F5 here, and you can see that our number never reaches the negative values anymore. It's never having to, let's see, where is this a good spot? Where's a good spot for this? Our number never has a chance to reach that maximum value. And since, or that negative value, since we're actually doing this at about 1 million frames per second, what if we instead used a break? We stopped doing this and we exited our program whenever we were done with this. So instead of setting number to equal 0, let's say break. So we stop going through our loop. So now if we hit F5 and run our program, we'll see it runs for about a second and then exits. That's all good and dandy, but it's not what we're here for. None of this is what we're here for. This is just an introduction. This is going to get a lot more complicated as we go. Don't worry. It's if you think this is complicated now, you have no clue. So let's erase number. We're going to get rid of that. What we want is to get the current time. Let's actually get rid of every reference to number. And we'll actually even get rid of our while loop. We want to get the current time, or actually we'll keep our while loop. Let's have fun with it. Let's keep our while loop. We want to get the current time according to the system. So I can now say within this right log here, or right line here, I can open up some curly brackets like I did before with the number and say time, let's see, system dot, oh, right. It's date time dot now. Okay, so now if I hit F5, I can watch as the time goes by. Now, this is a very titillating program so far, I know, but don't worry, programming gets much more exciting. This is just the tip of the iceberg. So, now that we've got the time, we can get rid of hello world. We can get rid of that portion of it. And that'll just show the time. And that's all great and dandy, but it doesn't really tell us, it doesn't give us any information or give us any progress towards creating a file on our desktop. So let's elevate this string here and give it a new life, sort of, so that I can use it later instead of having to rewrite out this whole line. So I'm going to say string value equals, and I'm going to take this, hit Control X, come up here, Control V, and then within this right line now, I'm going to write in value. And now I've got a little red squiggly underline because I need my semicolon. So now if I save this and hit F5, it does the exact same thing it did before. It's just counting up the time. Now, this is really handy, sure, but not for logging the time whenever I open the program. So let's just log the time once. So let's take this out, pop it up here, and then let's start thinking about how to write a program. So system gives us basic functionality, like we can write to the console, we can access the date, we can access several things using that, but we can't actually access the internals of the desktop or anything like that. And we're going to need access to things like that. So we're going to be using a subdirectory of system. We're going to use system.io. And this gives us access to the file system. Ooh. So from here, I can now write file dot write all text value. Now this also expects me to have a path. You see, if I hover over here, it says void file.writeAllTextString path contents +1 overload. It creates a new file, writes the specified string to a file, and then closes the file. If the target file already exists, it's overwritten. Now, we don't have a directory. We're going to need to get one. We could, theoretically, just write in our desktop. In fact, that's what I'm going to do for now. Let's just grab this directory here, and I'll write in text, just like that. Now, we have an issue. There are special characters within a string. And a backslash like this actually is one of those characters. So we need to add a second one to each of these. And this can be quite tedious. So let's just go ahead and go through and add them all. There we go. And you see it turns yellow. That's because it's a special character. So this will create the file on the desktop, but it doesn't know what file we're creating it at. So I'm going to create a second string, but I'm going to create it up here, right under program, and above my main void, because I want this to be a global variable for the program. It's going to be a string. Actually, it'll be a static string, and it needs to be static so that you can access it from within the static void of main. Otherwise, or because if you are static, if this void is static, then it cannot access non-static things or dynamic things. It's a whole thing that we'll get into another day. So for now, let's just have a static string file name. And I'm going to set that to equal timelog.txt. Okay? And let's copy that and come down here and say plus file name. So here's what the complete line looks like. Okay. I'm now going to hit F5, and we'll see that we've got our text or our log of time here, and then I've got a new time log text file. And if I open that up, it's got the same. Oh, whoops. Let's lower that. It's got the same time and all that as the text, which is quite nice. So what do we do from here? How do we, because I can run this as many times as I want, but all it's going to do is repeat this dialogue and just give us more, or give us the exact same thing over and over again, but with different values. So we need to actually be able to indent the current line and add in a new value to this text document. So to do that, we're going to say file.readAllText from this directory here. In fact, I'm going to elevate this. I'm going to hit Control X, come up to the top, say string dir equals this. There we go. It's just so we don't have to type it back in. So read all text from dir and write all text to dir with value. So we're reading all this text, but we're not actually doing anything. If I hover over it here, you see it says string file.readAllText from path. So it opens a text file, reads all the text in the file, and then closes the file. And you see it says returns a string containing all the text in the file. So that means that returns means that I can actually take the value that is being read from this and assign it to another object or another value. So let's take string here, copy it, pop it here. So string value equals read all text dir. Then here in the line below it, we're going to say value plus equals /n datetime.now. So what is this /n I've just added in? This starts a new line whenever I read all the text. But there's an issue here, because what if there's no text in the document? Well, we're not going to worry about that right now. Let's just go ahead and run the program and see if it adds in a new text document. And as you can see, I've got 2 time logs whenever I run the program. Let's close it, run it again. I've got 3 time logs now. Ooh, very cool. So if I open up time logs, you can see it's got the exact same output. So let's delete the file and watch as it throws an error. System.io.file not found exception. Could not find the file directory .text. Okay, so let's come up to get out of this loop here, we need to come up to build or debug and then hit stop. For some reason it accepted me closing the window, but normally you want to hit debug and then come down to the stop sign and hit stop. In fact, let's show that again. Debug, stop debugging. There we go. So what if the file does not exist? So let's set file to equal this, just an empty string. Come down below it and say if file.exists dir, then value equals file.readAllText dir. In addition to that, anytime, or instead of having this /n datetime.now, let's Control X that and put it at the end. We'll say datetime.now /n. So instead of adding a new line and then adding our content, we're adding our content and then adding a new line, so that the next time we add content, we will be already on the next line. So you could additionally add this in both places to add a space between your text, but I don't really care for that. You can if you wanted to. So now, if I were to hit F5 and run this, you can see that I've got my debug. And it's indented by a whole line here because, well, the console by default adds another line. So if I open this up, you can see I've got 1 time log. If I run it again, I've got 2. If I run it again, I've got 3. And yeah, it works. But it doesn't work the same as this other time logger program, which I displayed, which just opens and closes immediately. And that's kind of a issue of like opinion, I guess, how you would like your program to run. But one thing that we absolutely have to fix is that this program, the one that I have set up here, or this program over here, that I've set up, is set up to, let me actually I want to flip my camera here. Properties. I'm sure there's a way to flip it. I'll do it. Flip vertically. I could flip it vertically. Sure, let's do that. Let's flip it vertically. No. Anyway, it doesn't actually matter that much. At any point, this program is set up to only run on my computer, on my local desktop, within my OneDrive. So, there is a way around this. Of course there's a way around this. You've used computers. You understand that every computer has a method of getting around things like this. Here's our way to get around it. So we can write in special directories dot desktop. And you see this adds in a new using statement up to the top here if you're in the latest version of Visual Studio. If you're not, you want to write in up at the top using Microsoft.visualbasic.fileinfo. And by typing in special directories.desktop in Visual Studio at least, you just automatically add that in. So I'm going to take that and put it where my desktop directory is. And then I can just say dir equals special directories.desktop plus file name. That's simple. It really is that simple. We have just significantly improved the functionality of our program. What's cool now is we can actually make this run the same way as the other program by just removing our while statement right here. And it immediately closes instead of staying open, and we see it still works. It works exactly the same, or does it? Oh, no, it doesn't, because we've had an oopsie here. So, special directories.desktop only gives you the desktop. It doesn't open up a file directory within there. So we need to surround this in quotes like so, and then surround special directories.desktop in brackets, add some slashes here, and then add in this. So your line should look exactly like this. Rich text, open up some quotes, open up some brackets, special directories.desktop, / open brackets, file name, and then you end your string. Should look exactly like that. Okay, so if we hit F5, we see, actually, I saw for a moment there the actual program, which is kind of funny, but okay, I'll take it. You see I can run it as many times as I like, and then the text does still show up. Awesome! So, that's an introduction to C#. I would like to point out that if you're used to things like, I don't know, Java or JavaScript, you can just write in var here, and it will automatically define those values for you. Because C# is all about being open and welcoming to abstract values, and it's wonderful. You will love it once you get into it. You could even write object here, and that defines it as a string. Unfortunately, you then have to convert it back to a string down here. But it's possible. You can do it. Abstraction is wonderful in C#. I love C# because of abstraction. It makes it so much easier to automate programs that you don't know what they're gonna do. So, yeah, it's wonderful, and I love it. Thank you so much for being part of this stream, whomsoever it has been part of this stream. If you've got any questions, post them in the comments below, and I'd be happy to go over them with you. The only thing that's, well, this whole program is really, it's quite complicated. A lot is going on here, but it's all only 17 lines total. I would like to point out, whenever people say that their line count is, or that their program is 4 million lines and they're acting like that's so impressive, I just want to point out that that's
that is not an impressive feat. Having a lot of lines in your program does not mean anything, especially if you're a programmer. So let me just show you something real quick. I can actually reduce the number of lines in my project simply by formatting it differently. And see, I could even have these on the same line, and some people prefer to have their using statements all on one line. So this is a 9-line program. Oh. So this is a 9-line program, and it will run exactly the same. I've got an auto formatter, so it will automatically fix this whenever I'm done with it. But you see, you could even fit all of this onto one line if you were good enough with your formatting, and if you didn't really care about readability. So when people say, hey, I've got 1 million lines in my project, that doesn't mean anything. It means they've done a lot of formatting, I suppose, but it means nothing as far as how complicated the program is. Because this right here, this is two lines, and this will run exactly the same as the other program, which was 17 lines. So, and it's just as efficient too. And additionally, if you wanted, you could read this, and you could read how the program is going, or how the computer is going to be reading it, because it's all in the exact order that it's going to be executed. Ooh. So I could even, heck, bam, it's all one line. This whole program is one line. You're welcome, internet. So at any rate, yeah, the number of lines in a program is not, oh my gosh, look at that. 10 lines, perfect. I am a programming god. I made this in just 10 lines. As you can see, it really doesn't matter. It's just formatting, which is something that eventually you will learn more about. But actually, yeah, I would recommend looking into different ways to format your program. Obviously, there's one big debate of should it go on, or should this open bracket go on this line, or should it go on the next line? And that's that's entirely opinion, because some people prefer to say start working here and end the program here, whereas the people that aren't monsters say start working at the top after we've defined what we're doing, and then end it. And plus, it all being in line is a lot easier to look at. So, I mean, to each their own. I'm not going to tell you you're wrong, but if you are, you're wrong. If you're doing this the wrong way, you are wrong. I'm just stating facts. So at any rate, you guys have an absolutely wonderful night, and let me know if you'd like me to do another one of these. I am always down for a bit of programming, and if you would rather me do a programming challenge or something like that rather than actually showing you how to do this, but let's talk about namespaces real quick. So my program, whenever I started it, it had a namespace around it that said console program 1 or something like that. So what is a namespace? A namespace is these. These are namespaces. It's a way for you to hide your code from other programs in a very, very, very limited, abstract way to look at it. This is a horrible way to look at it, but it's a way to look at it. You can define certain... you can define this program as only being part of console program 1. And then you could have a separate... You could have this exact same code down here, have console program 2, and these are two separate programs. However, without the protection of a namespace, I get errors. And the reason I get errors is because the global namespace of program has already been defined. So to protect yourself from overlapping code, or overlapping ideals even, then you just protect yourself with a namespace. So yes, that is a basic, extremely basic introduction to C#. I would suggest highly looking into value types, their lengths and such, just for fun. It's interesting. And yes, have an absolutely fantabulous